Today we're going to talk about how to wire a standard sensor to your PLC and also how to wire an IO-Link sensor to a standard PLC input. In our previous video, we wired up our IO-Link module and we wired our laser, inductive procs, capacitive procs, and encoder to our IO-Link module that we could pick it up over Ethernet. But it's a really good exercise to go ahead and try to wire these sensors to a standard PLC input. Because even when you come to my class, everybody kind of gets the wiring of buttons and switches pretty good. We can figure out outputs, we can figure out motor starters. But when it comes to sensors, I think we struggle really hard with what is PMP, NPN? How does that correlate to syncing, sourcing? And yeah, how do we read the wiring diagram and figure out exactly how to wire these things? So first of all, let's have a look at our wiring diagrams. I've gone ahead and downloaded the wiring diagrams for all of these. And so this one right here is the laser sensor. And first of all, right off the bat, it's a little confusing because it has a push and a pull. And then here is our inductive procs. All right. And this one here, it's like, okay, is this PMP? Is it NPN? Sometimes you got to read through the weeds. So on this one, it says it right there. It's a normally open PNP output. And then over here, this is our capacitive procs. And we see the diagram up here. Still would love to see that word PNP and NPN, and it is right over here. And then finally, we have the encoder, and the encoder has wiring here, and it actually say PNP and NPN. I don't believe this one actually said on it anywhere. No, so this one doesn't say. So trying to figure out sometimes, one, what type of sensor do you have, and what type of inputs do you have? That can be the first challenge. So we have one IO link, we have two standard sensors, and then we have our encoder. So our standard sensors are PNP inputs. And we have, in fact, I don't know if I can zoom in enough, but if you look right here on your Compactlogix PLC, you have syncing inputs. Now, from our syncing and sourcing video, and that is up in the basic wiring chapter of this course, you're going to find this diagram that we used in the video. And so it says the following diagram can help you determine how to wire your PLC input or output. Put your hand over the type of input or output you are wiring. Your hand represents the PLC. What is left is how you wire your circuit. So we have a syncing input. Now I can't put my hand over it. You see it, but oh, there we go. I can scroll down like that. And so if this was a standard button up here, let's start with a standard button. And what we would want to do is feed plus 24 to one side of our button, and then the other side will go to our PLC input. And then we have the common, and again, no pun intended, this most common thing overlooked. But in our wiring enough to get started guide, we have already connected FP minus, and that is our common. And coincidentally, we didn't need it in the sync and sourcing video really, but we have the word PNP here. That's telling you if you have a syncing input, we need a PNP type sensor. Now, if we had a sourcing input, we would put our hand over the sourcing part and we would need an NPN sensor. In this case, this is what we have. And now we need to go figure out what exactly all this says. So this is a PNP sensor. And what this is saying is the brown, which is pin 1, is going to be our plus, and then blue, which is pin 3, will be the minus. And pin 4 is where we get a little confused sometimes because we see that pin 4, black, and then we have this thing here. And a lot of times y'all will reach out to me and be like, am I supposed to put a relay here or what is this? This little piece right here is actually the exact same diagram that I'm showing you here. It's only flipped the other way. Is we're taking pin 4 to an input on the PLC. And in this case, this rectangular represents the PLC. And then we need that common getting back around to the minus of our power supply. So the common for all the PLC inputs is FP minus, and that's that piece there. All right, so let's look at another one. Let's look at the capacitive procs. Now notice this is a Turk drawing. This is another Turk drawing. So not always are they going to be uniform through here, because here we have pin 1, pin 3, pin 4 in numeric order. Over here we have plus brown going to pin 1, and then we have our input black going to pin 4, and we have minus blue going to pin 3. So different order, but in the end, same result. We're taking brown as the positive, blue as the minus, and that is fairly industry standard. And the most important thing is figuring out if the black is an NPN or a PNP load. So black will be our input. And now let's look at the laser sensor, because this one's a little more confusing because we don't have that really clear thing that we had over here telling us, oh, it's switching over to this minus. But over here, there's a line going either way. This is called a push pull. And that means it can do either or, and it'll figure it out for you. So we are going to take the black wire again to our PLC input. And then, I don't, honestly, I've never done this before. I'm doing it right with you. I don't hold out really high hopes of getting a lot of info from our encoder being over here on a standard input. We're going to go ahead and do it again also. So in the end, on all of our sensors, the brown is the positive, the blue is the minus, and the black is going to be our input. Now, on our previous video, remember we wired everything to this terminal block, and this is part of the reason that I went ahead and put this in here. One, this is kind of simulates what you would see for field wiring on your sensors. But so in this case, we can leave our sensors wired just like they are. And also, remember we wired plus 24 and minus 24 to the back row and to the middle row. And so that means our blues already have the minus 24 on here. Our browns already have the plus 24 on there. And then these wires right here are our input. So all we're going to do is take these off of our IO link module, and remember the order that they're in. And then we're going to make port 2, which is the capacitive prox. It's going to be input 14. And then the next one up is going to be our inductive prox. And finally, we're going to have our laser sensor. And then we'll go ahead and power our trainer up. And now if you stick your hand in front of this, as long as this light's on, now notice if you get too close, the light goes out. And that's just the default setup. Then we're getting input 12 on. The inductive prox requires metal. So if we put a piece of metal over top of it, we get 13 on. The capacitive prox, we can use our hand. We stick our hand over it. That gets us 14 on. And I was kind of curious whether we would actually get anything out of the encoder. And no, it doesn't actually give us anything out of it, which honestly would be really difficult to actually get a lot of signal to a discrete input on an encoder. Now, I know a lot of you are getting ready to say, well, wait a second, Tim, can I wire a lot of encoders up to PLCs? Yes, you can. Those are called high-speed inputs. Our Micro 850 trainer actually has those. But in the case of the Compactlogix trainer, the standard inputs are just discrete inputs, and they would never capture any real pulse on that. Okay, so I know that seems like a detour since we have IO Link, and it seems like IO Link just makes everything magically work. But one day, I promise you, you will have to wire a standard sensor to a PLC, and that can be the most intimidating thing to do. So go ahead, even if you have the IO link, pop those off, make sure you see how they work, make sure you understand that wiring. And then, yeah, we probably will play with them some, but for now, we're going to pop back over to our IO link, which means we need to put those wires back up on the IO link module. And then we're going to learn how to configure them in either your Compactlogix PLC or your Micro 850 or your Micro 820 or your Siemens PLC. That's one really cool thing about the IO Link is this is compatible with Ethernet IP, Profinet, and Modbus TCP. So here's a playlist to get you started on that.